Hi guys, welcome to another video of Physics 2. In this case, we're going to see the problem number 3 about the uniform linear motion. So this is it. It says the International Space Station is a platform that is 408 kilometers from the Earth. It weighs around 420 metric tons and orbits the Earth approximately 16 times in a day. Find period, frequency, angular velocity, tangential velocity, centripetal acceleration, centripetal force, and this is a new one. Distance traveled in an hour. Okay, so let's go to this screen over here, and before I start with the problem, I'm gonna make the proper drawing about it. Okay, so um, if you see, well, I can make two drawings. For example, I can say that this is the Earth and there is a distance between the Earth and the International Space Station. Let's say that the International Space Station is over here and this will be the height. I don't know if I made myself clear, but that will not be the case because I'm going to consider the whole circle. I mean, all this distance, like the radius. Okay. So, for example, I would say that the International Space Station is over here. Okay, but I will not consider that. Okay. So what I'm going to do is that I'm going to say that this circle is the orbit of the International Space Station. So if you want, you can say that this is the Earth. Okay, this little circle over here is the, well, it's not, no, it's not that little, but we could say that that is the Earth. Okay, and the black circle, we could say that that is the orbit. Okay, but for example, let's say this. Okay, so that is the International Space Station, and it says that is 408 kilometers from Earth. Okay, so we could say that, I mean, that is just a circle. Okay, I'm gonna have to erase this. Okay, let's do it again. This is the Earth. Okay, that's the Earth. Okay, and if you see, we got the Earth has a radius, and that is an important data that I have to take into account. Okay, but the International Space Station is orbiting the Earth in something like this. Okay, in a big circle, just like this. Okay, and this is where the International Space Station is. Okay, and the distance will be 400. The distance from here to here is 408 kilometers. So that is an interesting data. Okay, but if I want to take into account that I need to consider the full circle. Okay, so I need to take into account also the distance, also the radius of the Earth in order to do properly this problem. Okay, and I guess I didn't do quite well. Okay, so I'm going to do this. Okay, that is the International Space Station, and with another color I'm gonna draw the distance. Okay, so this one over here is 408 kilometers. Okay, and also I need to consider the radius of the Earth. So what will be the radius of the Earth? Well, let's look for it. Earth radius. Okay, so is 6,000. I'm just gonna call it over here. Earth radius. Okay, and that's a data that I'm going to write over here. Earth radius equals 6,371 kilometers. Okay, so that means that the full radius that I'm going to use will be just as a sum, this distance plus this distance. So let's get the calculator. This is the calculator. Okay, so it will be 6,371 plus 408 kilometers. Now, well, if you see, it's not in a scale, but I had to do it so you can see the distance around, something like that. I mean, so this is the distance from the surface of the Earth, but we need to take into account the radius of the Earth in order to make this problem. Okay, so that would be 6,779 kilometers. So that would be the radius. Okay, now let's look at the other data of the problem. Okay, so the weight, well, that will be the mass of the International Space Station will be 420 metric tons. Okay, and orbits the Earth approximately 16 times in a day. Okay, so I would say that I'm gonna write that 16 times in one day. Okay, in one day, and I need to find all these things. Okay, so before I do anything, okay, so that's the drawing. This is the Earth radius, and this is the distance. Of course, it's not a scale. I hope you see that. I guess this is the most important thing about this problem over here. Okay, so remember that we are going to have a tangential velocity of the International Space Station, and also there is a centripetal acceleration that points to the center, and also we're gonna have a centripetal force. Okay, so considering this data, well, I can begin finding all these things that I need to. So let's say that I'm going to find first the frequency. So if you remember, the frequency is how many cycles in a period of time. So in this case, it will be I'm gonna do it over here. It will be 16 cycles in one day. Okay, in one day. But if you remember, the units for frequency are hertz. Okay, that is cycles per second. So I'm going to transform days into seconds. So I would say that one day has 24 hours, and 1 hour has 3,600 seconds. I'm using the conversion factor. Okay, so it is pretty easy because I can cancel days with days and hours with hours. So the answer that I'm going to have is cycles per second. So let's do in the calculator. So it will be fraction 16 times over 24 times 3600. So that will be, okay, that is the frequency. Okay, that is the frequency. How many? Okay, I'm gonna write it over here. Frequency equals 1.85 18, yes, 18 cycles per second. That will be hertz. Okay, and I'm gonna save this value in my memory A because I'm gonna need it. Shift STO A. So that means how many cycles in 1 second does the International Space Station? Of course. Oh, sorry. I forgot this. I forgot times 10 times 10 raised to -4 hertz. Okay, so that would be an answer that they asked me to find. Okay, so that would be the frequency. That would be letter B. I'm gonna write over here, that is letter B. Now, how can I find the period? The period, remember, that is the time that takes an object to complete a full cycle. So in order to find the period, well, I'm going to use a formula, and I'm going to write it over here, that it says period equals 1 over the frequency. You must remember that frequency must be in hertz, cycles per second, because the official units for period are seconds. So let's do in the calculator. So it will be 1 over the value that I got saved, oops, in A. Okay, so if you see, I got 5,400 seconds. So period, I will write it over here, period equals 5,400 seconds. That is the time that takes the International Space Station to complete one cycle around the Earth, and this will be the letter A. Okay, and if I want, I can save this value. Well, I'm not gonna save that value, okay, because it's a round value. Okay, now I got the frequency and I got the period. Now what else can I find? The angular velocity. So I'm going to write the angular velocity equations. If you remember from previous videos, well, angular velocity is 2p times the frequency, or angular velocity is 2p or 2 pi over the period. And I'm going to use this equation over here because I already have the period. Okay, so it's going to be 2 fraction 2p over period, that is 5,400 equals, okay, that is the angular velocity of the International Space Station. How many radians per second? Okay, so angular velocity, I'm going to write it over here, equals 1.1635. 1635 times 10 raised to -3 radians per second. Okay, and I'm gonna circle this, and I'm gonna save it in my calculator. Shift STOB. Okay, because I got this one in A, so I'm gonna save this one in my memory B. Okay, let's just see it if I already save it. And yeah, okay, so now I got angular velocity, that is letter C. Okay, what about letter D, tangential velocity? Okay, in order to find the tangential velocity, I'm going to use this equation over here. Okay, tangential velocity equals the angular velocity that I just find times the radius. Okay, and the radius that I'm going to use is the radius, the distance of the Earth plus the distance of the International Space Station, that would be this one. But remember that I need to transform this into meters. So let's do it. It will be the radius 6779 times 1000, because I need that number in meters, times the angular velocity, and the angular velocity is already saved in b, so alpha b equals, and that would be the tangential velocity of the International Space Station in meters per second. Una, dos, tres. If you see, that's a lot of velocity. That's a lot of speed. So I'm going to write over here. Tangential velocity equals 7,887.7246 meters per second. Okay, so that's a lot. That's a lot. So that's why the International Space Station completes a full cycle around the Earth in 5,400 seconds. Okay, well, I'm gonna save this value in my memory C. Okay, so I'm gonna circle this. This will be the letter D that I needed to find, and this value will be in my memory C of my calculator. Okay, that's an impressive velocity, because it takes only this time in order to complete one cycle. So how much is this in hours? So 5,400 over 60 minutes, sorry, over 60 seconds. So that would be 90 minutes. That's nothing. I repeat, that's nothing. Okay, so now let's find, okay, we need to find centripetal acceleration, to centripetal force, and distance traveled in an hour. I'm gonna write the equations that I have to find the centripetal acceleration. So we got centripetal acceleration equals tangential velocity raised to the square over the radius, or centripetal acceleration equals the angular velocity raised to the square times the radius. So I'm gonna use this equation over here. Okay, so first, well, remember that the radius must be in meters, so let's do it. So parentheses 6779 times 1000, because it must be in meters, times the value of the angular velocity raised to the square, and that is a number that I can save in the memory B. So alpha B raised to the square equals, okay, so that number is the centripetal acceleration, and I'm gonna write it over here. Centripetal acceleration equals 9.1777 meters per second square, and I'm gonna save this value in my memory D of my calculator, because I'm pretty sure that I'm going to use that number, and that will be in order to find the centripetal force A, B, C, D, E. Yeah, centripetal force. So I'm gonna write the equation for centripetal force. The centripetal force equals mass times the centripetal acceleration. Okay, so just remember that mass must be in kilograms, and centripetal acceleration must be in meters per second square. Okay, so the mass, I got it in metric tons, I guess, so I will have to multiply by 100. So let's do it. 420 times 1000 times the centripetal acceleration. Oh, I don't know if I, yes, and this value I saved it in my memory D. So I'm just going to see to do alpha D, and that will be the force, the centripetal force in newtons, and that's a very big centripetal force. So I'm gonna write it right here. Okay, so centripetal force equals 38, 54, 66, 9. Okay, something like that. It's a very big force, 0.446 newtons. Okay, remember that the centripetal force is a force that points to the center. Okay, so I'm gonna circle it, and that will be the letter F for centripetal force. Okay, now the distance traveled in 1 hour. Now the distance traveled, remember that is this distance over here. I mean, it's not the radians, okay, because radians is an angular distance or a circular distance, if you want to prefer calling in that way. So the distance in this case is linear distance, and remember that the linear distance is measured in meters or kilometers or feet or inches. So I need to find the distance, this distance. Okay, I don't know how much it's gonna be because this International Space Station is going to travel for 1 hour. So how much is that distance? Okay, so there is an equation, and I'm gonna write it over here. Okay, that says angular distance equals distance, angular displacement equals distance over time. Over radius. Okay, so I cannot use that equation because I don't know the angular displacement, and also I don't know the distance. So there is another equation that says tangential velocity equals the linear distance in meters over the time. Okay, so I got the tangential velocity that I just found, and I got the time. So I'm going to use that equation in order to find the distance. So distance equals the tangential velocity that multiplies the time, and the units are going to be meters per second. That is going to be multiplied by seconds, and seconds is going to be cancelled, and the answer is going to be in meters. Okay, so tangential velocity is a value that I just saved in my memory C. Well, I just want to make sure that yes, that multiplies the time, and the time is, how much is the time? Is 1 hour. So remember that I need to transform that hour into seconds. Okay, and 1 hour in seconds is 3,600. Okay, so the only thing that I'm going to do is going to multiply 3,600, that is an hour in seconds, times the value of the tangential velocity, that is a value that I got saved in my memory C, and I will find the distance traveled in meters of the International Space Station. If I want this distance to be in kilometers, well, I'm just going to divide over 1000, and that would be the distance in kilometers. So distance traveled by the International Space Station in 1 hour is 28,395.88 kilometers. Remember that that distance is the linear distance. They are not the radians. Is the distance around over here. Okay, it's not a distance measured in degrees or radians. It's a distance measured in meters. Oh, in this case, meters and kilometers. Okay, so this is the last problem of uniform circular motion. If you want me to explain more problems, well, make sure that you leave a comment in the comment section below. So take care, guys. Bye bye.